Hi ladies, so I'm just going to show you how to do some of the examples from your workbook so you can try them yourselves regarding naming alkanes, okay? So girls, this is on page 61 of your workbook. Okay, so this is it here. So you have to draw the full structural formulas and give the systematic names for each of the following. So here they've given you the chains, okay, and the branches are in the brackets there, so you'll see what I mean now in a second. And here they've given you the UPAC names, and you have to draw them then after that, okay? So it's a little bit different. So the only section you're going to be able to do here at the moment, girls, is 21.1 and 21.2. Then it goes on to alkenes, and if I can get a chance to do a video on that tomorrow, I will, okay? So before Easter. Okay, so 21.1. So 21.1, okay, so the molecule that it's giving me is CH3, CH, CH3 in brackets, CH2 and CH3. Okay, so first of all, let's draw this out. All right, so hopefully you can see that there. Okay, so CH3, so CH, that's the end of my molecule. Then you've got your CH, and see the way there's a bracket here, that means that there's a CH3 as a branch on our chain there, okay? CH2, okay, and CH3. Okay, so let's remember, for naming these guys, you have to first of all work out what the longest chain is. So your longest chain here is this. All right, okay, easy enough. And we have to number our carbons so that our substituent here, our methyl group, has the lowest number possible. So we're going to number from this direction here, because that means it will have the number 2 rather than having the number 3 if I named it from here. Numbered it from here. 1, 2, 3, 4. Okay, so therefore we are going to call this, so it's butane, methane, ethane, propane, butane. So it's 4 carbons, so that's the root of our name. So butane, okay, and we've got a methyl group, and we have to tell the other scientists where that methyl group is present. So it's going to be 2-methyl butane. Okay, so that's the first one there. Your second one, let's have a go at that one. So again, anything that's in brackets is a branch on our chain. Okay, so CH2, CH bracket again, so CH3, CH3. Okay, so let's have a little look at this one. So this one here, hopefully you can see that. So we've got CH3, we've got 2 methyl groups here on that carbon, and then we've got another branch here. So let's try and draw this out. So CH3, okay, C with a CH3 there and a CH3 here. Okay, so there's 2 methyl groups here. Just do a circle on those at the moment so you remember where they are. CH2, so just CH, CH. Again, there's another branch here. Doesn't matter which side you put your CH3 on there. You can put it around the other way because these bonds can rotate. And then you've got a CH3 again, okay. Okay, so let's first of all give the root of this alkane a name. So there's 1, 2, 3, 4, 5 carbons. So methane, ethane, propane, methane, ethane, propane, butane, pentane. Okay, so pentane will be the root of the name, and now we have to tell another scientist then obviously where these methyl groups are present. Okay, now there's 3 of them. All right, so there's going to be trimethyl. All right, trimethyl, and we have to give the carbons that they're on. Now we have to number this so that the methyls have the lowest number, okay? So we're going to number from this way because that means these 2 methyls will have the lowest number possible. So it's 1, 2, 3, 4, and 5, okay? So they are going to be 2, 2, 4, trimethyl pentane. Sorry if that's a bit squished. So 2,2,4 trimethyl pentane. So hopefully that's okay there. Now let's move on and do your 21.2. So I'd like you to try and finish the rest of 21.1 yourselves based on that, okay? So 21.2, girls, you have to draw the structural formula based on the name. So we're given 2-methyl propane. So the one to start with, girls, here is you look at your root. So propane. So hopefully you've learnt off your 10 alkane names now. So methane, ethane, propane. Propane means 3 carbons. So 1, 2, 3, 3 carbons. And this here is telling us that we've got a methyl group, a CH3 group on our second carbon. So CH3. Okay, and remember, every carbon always has to have 4 things attached to it at all times, so you fill in the rest of the H's. So there is the structure of our 2-methylpropane. That was A. Now let's have a go at B. B is 2,6-dimethyl-octane. 2,6-dimethyl-octane. So octane, our root, is 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Hopefully that's right. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Okay. And we've got 2,6-dimethyl. So here's our second carbon, CH3. And dimethyl means you've got 2 methyls, 2 CH3 groups. The other one is present on the 6th carbon. 1, 2, 3, 4, 5, 6. Doesn't matter which side you put it on. Okay. And then what we have to do is we have to make sure that every carbon has 4 things attached. We fill in the rest of hydrogens. Okay. Alright, so there is our 2,6-dimethyl-octane. So girls, if you could have a go at the rest of 21.2 as well, that would be really good. Now I know this is hard doing this on your own, but try and use your textbooks to help you, and try and review the videos and see if that helps you too. There's some other really good content on YouTube as well, girls, that should be able to help you. But give it your best shot, that 21.1 and 21.2 on page 61 of your workbooks. Thanks, girls.